So today I'm going to be repairing this HR2510 radio. Now I've actually started doing this repair video years ago and I've got distracted a few times, moved on, gave up on it for a little bit, did some other stuff because it's getting a bit complicated and hard. I thought, it doesn't really need to be done right now, and I moved on from it. It's got some very interesting faults, very rare faults actually. So we'll cover those and you get to see what I do to fix those problems. It's quite a lot to cover. It's got several faults. There's a few little workarounds I do on this. Quite an interesting one, which is quite unusual. In the end, I do get it working, so I'm actually recording this after the fact. Stick around, see what I do. It goes from being dead and weird to working fine. So I started working this radio about 5 years ago. Right, so that's my original footage. So you see some of my original footage is quite old, different kind of style. It's even recording that on my cell phone, I think. So when I first started doing YouTube is when I started doing this repair. So I shelved it for a while and I kind of forgot all about it, to be honest, and it's been sitting there for years, and I thought, oh yeah, I should really finish that thing, get it working. Okay, so the first thing I'm going to do is check the TX out pin from this board. Oh, hold on, that plug's not in. That might make a difference. Let's plug that in. No, it's not a transmit, so that's not that. Right, so back to where I was. So I'm just going to earth on here, on the chassis, which is good enough. It's not perfect earth, but it's good enough. The TX pin is pin 1 of J302, which is this blue wire just here. So I'll stick that in there and stick it on voltage. No, hold on, I need to do this backwards. This isn't right because it's pulled down. I need a voltage. It's negative going, so I need to make sure I'm going between that and a positive. So we'll stick that in there. Not seeing anything happening there. But, okay, I'll put the probe on the main DC input and I'm probing in there, and yeah, that is pulling low. So there is TX out from the CPU board. Okay, so the TX is coming out the board. So the question now is, what else is wrong? Is there a frequency issue on this board which isn't getting out? Or is it a TX fault on the radio where someone's been screwdrivering it? I mean, all those slugs look like they turned right in, every one of them. So it could be this board is so far out of alignment it doesn't work. They all look like they've been screwed in. I think this is where I'm going to have to look next, is on this board actually, before I go chasing TX voltage faults. Okay, let's go for this. 28 megahertz. Yeah, that is wrong. And that one there looks about right. What are we getting here? No, that actually looks pretty close. Let's just try a different band. Well, a different mode, sorry. It's off tune, it's off alignment, but it is changing. So that appears to be okay. It needs aligning, but it's there. Right, so there's 38 megahertz coming out of there. So I can ignore that for now. I do have to come back and realign it, but first things first, get the thing to actually work. So that means there must be an issue with probably DC switching over here. This usually happens is one of these transistors fail over here and it stops transmitting because that's gone. So I need to just double check the diagrams to see which one I need to be looking for. So I'll be right back. Okay, so I want Q125, which is just here. Now I want to check the emitter and the base and the collector to see what they're doing. And the pinout is ECB. So I want the collector is the center pin. So the first thing I'm going to do is look straight at the collector and see what was going on there. So center pin, no voltage right now. TX, we have voltage, 8 volts. So as far as this is concerned, it is going into TX, which means it could be someone's just been screwdrivering it and it's just a mess because of that. Or it's not getting any further than that point. But as far as that's concerned, TX is happening. Although various capacitors in this board will probably need replacing as well, probably, you know, all of them. It's also got that bloody adhesive, although it's not very dark yet, it's looking quite good, it's not too dark, so I need to pick all that off as well and get rid of that. I wonder if I should check receive, if there's any receive life. Actually, I'm going to start a bit of alignment work and just see if what I can find from that. Okay, so let's hook onto this. We shall check the frequencies of this oscillator here. See if they look about right or not. The offsets are slightly wrong. Yeah, it's there but not great. It's not looking right. It's living no life in any of the modes. But I think there's going to be multiple things wrong with this. I think I may have to resort to recapping the whole radio and seeing what faults are left after that. It's time consuming, which is a bit of a pain. I don't want to spend a lot of time on this thing, but I think I'm going to have to, because the kind of faults I'm seeing is probably related to that. Let's see what I can get. The scope over here. So someone's been playing with this. I just want to see if I've got any kind of RF at this end. Where's the transistor? See it somewhere. I think that's it there. I've got nothing there. I'm seeing a spike, but I've got no RF at that point. Okay, let's try there. Stick it in TX like that, and never twiddle with this. See, nothing going on there. Nothing on the output there. Yeah, I don't know. I'm getting 38 megahertz here, like I should be. There's a mixer just here. I might just probe around on that and just see what's going on there. But yeah, I'm just not convinced. So that should be output mixer there. Yeah, I don't know. I'm going to have to come back to this, I think. Narrow it down some more. I'm going to start doing it like some alignment stuff on this radio, right? To try and identify where the faults are, because that's usually a good way of actually finding out which bits aren't working. Now, one of the things I've identified, which is only slightly wrong, is that this crystal here is not generating the correct frequency. It should be 22 megahertz exactly into this IC, and it's not doing it. It's off frequency, and that's a common fault with these, and I'll tell you why. This crystal has also been replaced. It's not sitting flush on the board, and its legs are slightly long. Someone's replaced that crystal thinking it's faulty, I think. What it actually is, it's just here as a series capacitor, service mount capacitor right there. That goes off value. So if you take that capacitor out and replace it, it brings it back in the line. If you ever get this issue where the crystal can't be tuned, change that capacitor. That's usually all you've got to do, and let's realign it then after that. So I'm going to do that now, and I'll come back and carry on with some bits and pieces. I should probably recap the whole board, but first of all, I'll get this frequency right. Right, so I've realigned this whole entire MPU, MCU board. I think it should be MPU. Anyway, this chip here, right, this board, I've realigned it all. I've gone through every single adjustment and realigned them all, and it's all good now. It's all bang on frequency. These have been played with, these have been played with, that down, that one there. Yeah, they're all off, and that one is way out because of that crystal being wrong. I ended up changing that capacitor to be a 47 PF. It's supposed to be 100 PF from the manual, but I think because someone's changed that crystal, it's slightly off value compared to what should be there, or different loading or something, and so it affected it. So I had to go to 47 PF. That's now tunable at least. So it's all, this board is all working correctly, and it's all good. So I haven't changed all these other capacitors. I said they are Rubicon caps anyway, so you know they're good quality capacitors. I've changed these ones obviously because I was in the area and I was having problems in the area, so I've changed those. But everything else seems to be working fine. So unless I see a reason to change the other caps, I'm going to leave them as they are. I mean, if I was doing it properly, I'll just replace them all. But you know, they are getting old now. But anyway, it's, you know, that board is working. The radio still is not working. Okay. The next thing I need to do is to trace on this board what's going on. So the first thing I'm looking at here is the TX side, because as I've already proven, the TX switching is occurring. Now what I've had a little look at already, just down here is the output of the mixer here. Right, that's the mixer just here, TX mixer. Probe on there, and then I check the transmit. I'm getting a different frequency of what I was getting before, which is interesting. I was getting 40 megahertz before, now I'm getting 36.16975. Yeah, which sounds like a correct frequency to a point. So it could be a weak signal from probably this section here. Now when I was probing that earlier, I was getting issues with it being a bit weak and being a bit strange. It wasn't quite behaving what I expected to. So, I mean, it is weaker than I expect. It's only 340 millivolts. I'd expect to see a higher level than that. It could be a power supply fault. It could be a dodgy capacitor in the area dragging it down. It's entirely possible. And that's interesting. Very interesting. What I'm referring to here as being interesting is when I'm changing modes, the channel display is changing. Well, the frequency display is changing. Let's bring this up. See that? That's something to happen. And that's not working now. See that? That's working that band. So on AM it works, FM that works, USB it doesn't work, LSB it doesn't work, CW it does work. So upper sideband, lower sideband is stopping the channel slip from working. And when you switch them, it's changing channels. There must be some kind of short there. I need to look into that. So I'm just tracing this TX fault, and I haven't looked at the RX side at all yet. Well, I've looked at to see there's nothing there. That's enough. Which means there's probably a common issue there, which I'm thinking is correct. On the TX mixer, which is just here, you can see there are 6 pins along there. Well, sorry, what was it, 8 pins? Is it 2, 4, 6, 8, 9 pins. Right, TX mixer's right there. Now, pin 6 should be the 38 megahertz at 20 when you're at 28 megahertz on the display. It should be 38.695 or something from the VCO MPU board thing, right? Which is that pin right there. Goes in to that pin there, which is from this jumper which runs up here. Well, it's actually a resistor, I think, from there. But okay, so that one there is 38 megahertz, 38.6975, whatever it's been, what mode you're on, right? Which is fine. And when I go to TX, that's the output here into that filter network. That's 3 tuning cans which are in a row. And at that point there, if I transmit, I'm getting 38 megahertz coming out, which means it's not mixing. And that's usually as a result of a missing signal. So if I trace through, I looked at the circuit diagram, and the other input should be pin 2. So pin 2 here should be a 10 megahertz signal, and I'm getting nothing. There's no 10 megahertz there. Right, so the fact that 10 megahertz is missing is a good indication about that's what the root cause is between the TX not working because there's nothing to mix, and the RX also not working because it needs that same signal to mix with the RX side in order to correctly convert the 26 megahertz to a signal we can interpret, or 28 megahertz, whatever it's set to at the time. Right, I need to look at that 10 megahertz signal. Now I know I've got a 10 megahertz because I was looking at the mixing side of things, and I've aligned the crystal, so I know that is working. So somewhere between that crystal and this point here, it's being lost. And now there is a transistor in line with that, which is, I believe, is like a buffer amplifier thing, right? So it's obviously not getting through that. So I need to trace that down. But there is a electrolytic capacitor there, right by that transistor. What I'm thinking I might do is just recap the board. I know this board's working, apart from that weird glitch with that band thing. So I might have to recap this board as well. After all, if it needs doing, it's doing. That 10 megahertz is missing. So what I think I'm going to do is pull it apart, recap the entire circuit board. I might as well do this one as well while I'm at it. Just do the whole thing. Just do the whole radio is recapped, and then go from there and see what happens. Right, so I'm just going to show you the very last capacitor. I'm changing all the capacitors on this board here. I've got the last one to do. I'm just going to show you the technique I'm using for this, because being a double-sided board, it's a bit tricky to desolder and get the parts out, because you've got to get the heat right through the board and that sort of stuff. So, and it's easy to damage it if you're not careful. So what I tend to do is I actually put a big blob of solder, I've already put one on there now, and heat up both sides of that capacitor leg at the same time, both legs at once. Right? I mean, the desoldering gun works, but it's actually not as easy, because the tolerances on these holes versus the component legs are really small. So what I do is I put a big blob of solder on there, heat up the whole thing, because both legs at once, right, like that. So the whole component can then be pulled out. Just got to get the heat right through the board. Nice and gentle. There we go, components out. Okay. Now, I use the desoldering gun to clean the holes out. There we go. Alright. So that's a nice easy way of doing it. That's the technique I use to do it, and that's what works quite well on these double-sided boards, where it's hard to get enough heat mass through the board and to actually desolder. You know, using the desoldering gun, sure you can do it, but I find it easier just to do that blob and then use the gun afterwards to clean the holes. So that's that board basically. I've got to resolder these existing parts. I have done about 3/4 of this board, so I've done all the ones across here up to here. Basically I'll stop there. I've done right across here. I haven't done any of these or any of these ones here yet. I'll do testing first. I mean, that's the bulk of the important stuff covered, right? This is the audio amplifier section, and there's some RF section, and this is AMC and stuff. So that's, and signal meter. So if there's any problems in those areas, at least I know. Yeah, I've got to change those too. I'm being a bit lazy really, but basically my neck has started hurting from working on this for so long, so I don't want to do too much more, otherwise I'm going to end up getting a wicked headache. So I'm going to just leave it at that for now. Okay, so that's that. So I'll just give you some idea. This is the pile of capacitors I've taken out so far. MPU board is completely done. Looks like someone has replaced some capacitors in the past. This one here isn't the original one. That's been changed by someone. As this one here, they were both on that main board. So yeah, someone has been changing caps in it in the past, but I'd change them anyway because who knows what condition they're in, what quality they are. Right, a little bit of progress. Now I've done that recapping, the radio will now actually try and transmit. 1, 2. Alright, that's on FM. Okay, FM is transmitting. That is working okay. But I've been seeing some small strange behaviour. The current is increasing as I'm transmitting. So I think there's an issue with a shorted final or shorted driver. One of those two devices is drawing more current as it's transmitting. As it gets hotter, the current's going up. Also, AM doesn't work, but there is a current increase. That's like it's trying to transmit, and if I do it on AM, it goes up and up and up. It gets like 10 amps, and that's when I stop transmitting. Right, because it's getting a bit much. Just throttle my power supply back a bit. I don't want to put too much current into the radio. I've already reduced the power output down to 7.5 watts. It was to be 15 on FM. So yeah, sideband is working, but again it's got the same issue with the current going up. Something is not happy, and it's also changing frequencies still. I'm not quite sure why it's doing it yet. And this is getting quite warm at the back here, so I think there's a dodgy final or a dodgy driver, or it could be some self-oscillation even. It could be that. It could be something like that going on. So I've got it closer, but there's still issues where changing modes is causing the channel display to change, or the frequency to change, which doesn't make a lot of sense. Basically what happens if I'm in LSB, all the front panel controls don't work, right? Like the span, scan, span, F-lock, and channel don't work, right? Those tie directly to the MPU. There's like a row and column system it uses to know which button's being pushed. And in our upper sideband, same deal. It disables them, right? In AM and FM, they work just fine. CW, they also work fine. So it seems to be lower sideband, upper sideband selection. So something a little bit weird is going on here. So at least I've actually got some kind of activity out of it now. Let's see if I've got any receive. Yes, the radio will now receive. I can see a signal on the display. So RX is working, TX is working, but there's some weirdness happening still. So we're getting progress. Now what I'm looking at right now is the issue where you change bands and it affects the channel and locks up the controls. I've did some voltage checks on the actual connections here, which is the brown and the orange wires just here. Right, those are the sideband, and brown, the yellow is CW, I think. And when any of those modes were on, they dropped down to 2.7 volts on the other wires, which means me think, okay, there's an issue with any loading on here is dragging the voltage down, which seemed a bit odd because it's going through a pull down resistor network, which means it must be a positive supply issue because it's got a pull up resistor here, right? So I thought, right, okay, I'll measure that voltage at the common of that resistor array just here, and that was dropping down to 2.7 volts. It's like, that shouldn't be happening. That should be 5 volts all the time. So then I measure between here and the diode which feeds it, right? So the 5-volt supply comes through this diode, which then connects to various traces through the board, and one place it goes is to there, that common pin there. I'm getting a high resistance. I'm currently getting 1.2 mega ohms. That's not right. It should be a direct connection. Now on the back of the board here, there's the resistor array. There's the common, which goes to this pin here, which is pin 17. Okay, and it also jumps across over here to pin 13. Those two there join together just fine. Okay, those are 5-volt supplies for the chip. So that connection to the chip there is fine. But if I come over to the voltage regulator again, through that diode there, wasn't it? Just there. High resistance. Just like, something isn't right. Oh, sorry, this diode here, sorry, this one here. So there's an issue with the trace from this diode to those ones. So what I think I need to do is put a wire link across, unless I can find which trace it is, and make sure I get the proper voltage supply. That might fix that issue. The other issue I've got right now is that issue with the current jumping up or drifting up as it's transmitting. Now I've actually lost transmit now. It was working, now I've lost it. I've replaced every capacitor on this board now, on that big board, apart from the main bulk capacitors on the cost of DC supply coming in. The others haven't changed because they don't affect anything really. I've lost transmit to a point. So I'm at a bit of a loss with that part now. I've resoldered a lot of the back of the board here just in case there's a bad joint. I can't see any crack traces or anything like that going on, but what's happening is the IF power is dropping down and the current draw is going up at the same time. So it says those are short, but heat relators, I've tried heating up things and cooling things down, can't really see anything. So yeah, but I thought I'd just work on this now, have a bit of a break from the RF side because that's driving me nuts. And I thought I'd come down and look at this section. Now I've actually found something here, so I'm going to carry on with that and go from there. So I think I might have found a problem here. Now where this has all been dug out, there used to be glue in here originally. This has been dug out, not by me but by the person prior to me. I've been trying to clean this up. Now if you just try and look in there, you can see there's tracks. I get the light on it right, might be able to see it, but there's actually a break in the track just there. And this one here has also got a gouge out of it. So I've been cleaning that up, trying to get it a bit better. There you go. You see the breaks in the tracks and the scratches and stuff on there. Okay, so I'm going to resolder over all that and bridge all that up and fix it. And we'll see if that resolves the issue. It might be that the track is the one that feeds it. Okay, so I've bridged across those dodgy traces there and restored those. And I did some probing. And yep, sure enough, that little track that goes across here, the top one closest to this resistor, which had the break in it, is the one which goes down to that resistor. It goes down to a wire here, and it snakes down. Based on resistance measurements from here to here, it's a connection. And I've just gone to the bands and pushed the buttons on the front, and it's working now. So that's resolved that problem. So it probably relates to when someone's tried to modify this for the extended frequency coverage, and they've done it wrong, shorted it out, and blown that track out. And then blown that regulator out and have a track that goes across to here and goes down to there. Probably one person's mistake has done all that damage in that bit, most likely. So that is now fixed, that part. So at least now I'm be confident that the MPU is working okay. So I'm 100% sure now that this board here is good. Now I just need to fix the RF issues. So it's a pain, but we're getting there. We're getting progress each time. We're getting progress. Someone's been messing with it, and there's like so many things wrong with it. You know, I was hoping it'd be nowhere near as bad as this, but anyway, that's what you get. Well, it's been a long time coming. I last worked on this radio back in 2017, and at the time I had a fault, and I couldn't pin down exactly what it was. I had some ideas, but I never actually finished repairing it. I finally come back into my second lab here. I thought, right, let's get stuck into this thing. So I started working on it yesterday, and I was trying some things out, and I couldn't actually pin it yesterday again. And today I did some other stuff, and I've got one of the faults sorted out because I had multiple faults. Now the fault it was left out in 2017, which is as far as I got at the time before I shelved it and went on to do something else, is when you transmit, it wouldn't have to be transmitting, but you can actually see the current draw over here on the power supply. It just go up and up and up and up and up. And even in RX, it'd be sitting there in receive and the current would gradually creep up. I tracked that back to being an issue with the biasing. So I actually found that if I turn the bias all the way down to lower the voltage on the final as much as possible, that wouldn't happen. But if you transmitted, it would gradually creep up again as it all heated up. So that's what I was left with. Anyway, I've solved that problem, and it was actually just a bad final. If I can find it, it's here somewhere. Here we go. Got lots of mess on the desk right now. So HR2510, it's a real shame. It's an original HR2510, but it's got some leakage problems. So what was actually happening is the collector was leaking towards the base. So what that means is that the collector voltage, which is around 14 volts or so, you know, your main supply coming in, goes straight to the collector. And that was basically leaking through the transistor back to the bias circuitry, which was biasing the voltage upwards, which is why I had to turn it all the way down. And it's also backfeeding through to the driver bias as well. It's pulling that one up at the same time. How I tracked that back was, you've got this jumper link in here. Let's pull this out. You normally take this out when you're doing calibration stuff. You know, you check the currents on each one. You tune those to be like 50 milliamps or something. I pulled it out and I was measuring the bias level on the driver over here with the oscilloscope, which is running right now. I was measuring on there. You can actually measure it on that inductor there, which is what it's a kind of inductor. It's a ferrite bead with a wire through it. There's also a wire link right in front of the final and the driver. In this case, it's the driver. You can also measure on that as well, same place. I was measuring on that and I could see about 200 millivolts, 230 millivolts or so with the radio in receive. When you're in RX, there should be no voltage on the bias. So that's strange, you know, and because of the issue I was having with the current gradually going up, stuff like that, I was tending to pull this jumper out quite a lot. And I pulled the jumper out and noticed that the voltage disappeared. I thought, that's interesting, that shouldn't happen. Because this jumper here, that supplies the main supply, like the 14 volts, 13.8 volts, whatever you want to call it, through to the collectors. That's what that does. Well, if I'm shoving it in, I'm getting a voltage come up over here, it means the voltage must be coming from the collector side. And I did some jumping around in here, and I determined that the issue was if I jumped to the driver, it didn't happen. But if I jumped to the final, it did happen. So that narrowed down to the final leakage from the final system. I managed to track it back from that. So I desoldered the final, which is a real shame. So it's an original MI477, almost impossible to get. And if you can find one, they're damn expensive. So I pulled it out and like, okay, problem's gone away, no more leakage. Then you face the problem, okay, well, you got a blown final on these things. What'd you put in? Well, there is a modification which Uniden actually did originally. And I was fortunate enough to see a radio with this particular modification in it. And ever since then, I've been able to do this modification. So if you can't get an MI477, you can actually put in one of these other devices. Now this is a different one. Let me just focus on this. So this is the modification. It's not pretty, but it works. So what we actually use is an SRF3775. As you can see, it's a completely different package. So what you actually have to do is detach the rear panel, drill holes in it for mounting, tap the holes there as well and tap in the 3mm whatever, and mount them on the back panel. And then you run some wire links down to the original traces and stuff on the board to wire it in. You can see I've got a couple of wires coming out. I've got one, that's the 0 volt rail there on each side of it, plus the top and bottom sides, well, left and right sides because it's sideways. They're both 0 volts. They go to the centre track. And I've actually got a wire coming up as well. And it's also linked onto the back panel, so you have to link both of those terminals. You can't just do one, even though you measure across them and go, okay, it's the same connection. It's not. You have to wire both of them, otherwise you don't generate the full power. So you have to wire both of those up. That one there is the collector, that one there is the base. And across here as well is a 330 picofarad capacitor between the base and the 0 volt side of it on the transistor, just to help get rid of any self-resonance and stuff like that and self-oscillation. So you do that modification. It ain't pretty, but it works. Now this is based on, like I said, the original Uniden based one, which actually had a little circuit board with that device on it. And I think this device you also can't get anymore. I think these are even obsolete now. But I bought a bunch of them at the time. As soon as I've discovered this particular modification, I bought a bunch of them and I've got a few left. I haven't run out yet. Thankfully I haven't had to do this particular repair very often. So I've had to put that in there. That's now done. So that resolved the transmit problem and that current and the biasing and that sort of stuff. That is now absolutely fine. That works fine. I'm getting 10 watts out of it, and I'll show you that in a second. but I've still got another fault left to go. It's not completely fixed. So there's my bird watt meter. I've got a 25 watt slug in there. If I'm on FM, which I am now, if I push the TX button on the front panel, there we go. So we're getting just over 10 watts out at that frequency. And I can go through all the bands. So that's at 26 megahertz. If we go to say 27.6 megahertz, do that one there, still 10 watts. Now the thing with these is that people tend to mess around with one of the bandpass filters on there, and it's really hard to get that back when that's been messed with. I spent about 10 minutes probably tweaking that, trying to get it back so it's fairly even again. You know, 28.6, that's pretty good, and 29.6, there you go, 11 watts. So it's not dead flat, but it's pretty good. It's good enough. Back down to 26.1. Okay, so a watt here or there, so what? Doesn't really matter. Literally, ignore the pun. So receiver's working, transmitter's working, apart from AM transmit. AM transmit is not working. FM transmit works, the sidebands work, they all receive, but there's no AM transmit, which is what I'm currently trying to determine what's going on there. Because AM, there is no transmit. There's nothing happening here. Got FM, it's fine. Right, if I turn the beep on, you can hear it in the radio. I've got set up over there, even though it's on AM. So that's what I need to try and figure out what's going on. That's the next thing. I've got some ideas, but it's not particularly clear about where this particular fault could be, because the AM and FM, they're basically shared paths. They're very, very similar to each other. It makes it a bit trickier to try and determine what's going on, because, okay, you think, well, what's different? Well, there isn't really anything different. That's the problem. There's only a couple of slight changes between AM and FM. So either it's a band switch problem, or potentially there's a switching thing over here by a mixer. There's a transistor and switching system over here. I need to investigate this part. But I'm also going to physically check the band switch in case maybe there's a problem there, but I don't think it's the band switch, say, because AM receive is working, which means it's likely to be the band switch is fine, because that seems to be doing what it needs to do. It switches the oscillator section here for the IF, so that's obviously working. So I don't actually think it's a band switch problem. I think it's electrical switching over here somewhere. That's my current guess anyway. I need to look into it yet. And what I also did as well is I did a modification to this thing. Now it did have the original plug on the back, which is used for external speaker and PA and stuff like that, but it's only got like 3 pins in it, so it's basically a jumper plug. So what this normally does is it has a loop out and back in again, which enables the internal speaker, and if you break into that loop and switch it, you can then plug an external speaker in, right? So someone actually had this socket here on the end of this plug, and the wires are falling off, so I was like, well, okay, that's rubbish. So something I've always done with these radios is I've actually drilled a hole in the back, mounted a 3.5mm mono socket on the radio, right? So that socket there is a mono one, which is, so like I said, is on the outside the plug here. Get rid of that, it's rubbish. And now it's got a standard 3.5mm socket on the back for an external speaker, so you just plug an external speaker in and it will work. And it switches between internal and external, right? So there's the internal speaker wires there. It's a nice little modification I do to all these radios whenever I get one, because I do kind of need it. I don't actually understand why they did it this weird, obscure way, instead of just putting a socket on the back. Bit weird, anyway. So I've done that modification. That makes it a bit easier to do testing as well, because you just plug a speaker in. So let's measure the band switch outputs, at least one group of them, and let's make sure that those are definitely switching correctly. So the red wire, there's a little connector here which has got 6 wires on it, main board. So red wire is 8 volts, that's the main common. So it doesn't matter which mode I'm on, that's always 8 volts, right? So the next one over, which is the brown wire, that's that one there, that appears to be FM. Check all the other modes, yep, nothing there, that's FM mode, so brown wire is FM. Orange wire, that's AM, there we go, 8 volts there for AM. Check the other modes, yep, nothing there. You've got a yellow wire, that appears to be LSB, it's the last sideband. Yep, nothing in the other modes. Blue wire, that's upper sideband. And then finally we've got, what's that, grey wire, purple wire is it? That's 8 volts on CW. So all those seem to be working correctly. At least the band switch section looks fine. I looked at the band switch visually, it looks fine, I can't see anything wrong with it. So I don't think there's a problem there, but there is a second set of outputs on there. So that's one set of outputs, we need to look at the other one. Okay, so the other plug is over here on the MPU board, the other side. It's just here, it's a 4-pin plug. It's got a black, brown, orange and yellow wire right here. So the black is the common. So it doesn't matter what I do with the band switch, that's always low. This gives a lower output, okay? It's inverted from the other one. So we've got a brown wire. So it's high unless it's in upper sideband. So it goes low when it's in upper sideband. If the other mode is high at 5 volts, pulled up. Okay, it's got a pull-up resistor on that board. So the orange wire is lower sideband. So if I go through, lower sideband is low. And then you've got a yellow wire, which is high apart from CW. So when in CW it goes low. So that doesn't actually care about AM FM switching. So that does not matter. Which means it has to be some kind of electronic switching on the main board which is causing the problem. So now I'm going to check for the switching of the AM modulator section. Right, so you've got a resistor right there which is Q129. And here we've got a resistor which I think is R181. So this resistor right there, which I'm probing, that is the signal line that comes in between modes. So in FM that's high, in AM that's low, all the other modes also low, also high, sorry, get it right. So AM is a mode which it pulls low at, which means it's turning off that transistor, because it's an NPN transistor. I'll show you on a circuit diagram in a minute. Okay, and on this side, I'll show you the scope in a minute. I'll show you the scope now. Let's do that. So I'll show you what I was seeing at that particular resistor, the same spot I was showing you just then as I was doing those changes. So that is FM, AM, upper sideband, lower sideband, and CW. Right, so there is a slight step up there because it uses diode steering for these voltages, so there will be some slight changes there in some places. Okay, but AM is low, that's the critical thing there. Right, it does have a very slight voltage there, but it's almost nothing. What we got there, 226 millivolts. That shouldn't really be an issue. On the other side of the resistor, just here, let's say it's R181. Let's improve this level a little bit. So we're getting what, 142 millivolts there on AM. Here we're getting 785 on FM, upper sideband, lower sideband, and CW. Right, so about 770 or so is obviously what it's using to turn that transistor on. So here's the circuit diagram for this. Now Q129 just here, as you can see, right there. That's the device we're looking at least for switching. That's the AM modulation switch. And what I'm going to do is probe here. This is L109 because it comes through, passes through here, and then gets into this device, which is the mixer. So this is how it mixes in the modulation. So if I probe on L109, that'll tell me if the modulation is at least getting through and help narrow down a little bit, hopefully, what's going on. So I'm going to show you this. I'm going to obviously still see the scope. So I'm set up, ready to go. I've got my Marconi injecting audio, so I can use that as an audio test. So I'll probe this onto here. This is on L109. So watch the scope. Go to transmit. There we go. There's the audio. So it is modulated. That's on AM. That's on FM. No modulation, but high. Okay. AM is high with modulation. SSB is high. CW is high. Okay, so it's high in all states. In transmit. In receive, it's low. So there is a voltage there. So it's on FM, AM, upper sideband, lower sideband, and CW. Right. So there is a bit of a voltage there on the sidebands. Up and lower sideband, there's a slight offset voltage there of 700 millivolts. So it's doing some kind of switching there. I think it's got some diode steering there through D142. Where's D142? If I can find that, I can check for that. There's D142 down here. Yeah, it's coming from there, I think. I don't have the circuit layout with me. Only some components are labelled on the board. The resistors aren't labelled. Capacitors aren't labelled. The only things that are labelled are inductors, diodes, and transistors, and the VRs. Resistors, capacitors aren't marked on the board, so it makes it hard to deal with. So yes, definitely a modulation and a voltage offset on transmit with audio on AM. So that's what we're supposed to be getting there, I think. So I can't fault that bit either. So what I'm looking at now is the output from Q134, rather the input to Q134 out of the FT104. Okay, so in FM, which is what I'm modeling right now, if I transmit, you can see we've got a carrier there. I'll just do this without any audio. Alright, so we've got a carrier there. 30 odd megahertz is picking up there because of the waveforms and stuff. It's not particularly tidy. Not the best probing, I'm afraid. So on FM is there, okay, so I'll go back to the same pin when I start out on. That one there. FM, we have a carrier. Get an AM. We have nothing there. We do not have a 26 megahertz carrier going on AM out of that filter. Okay, you know it's at least before that point. So we've got this mixer over here. This is what I need to check next to see if all the inputs appear to be in it. I mean, Q129 was just there, that's what we looked at before. This is where I measured the modulation and the DC offset voltage. So it's doing something. So we need to see what's going on. It's got pin 6, pin 2, 3, 1. Pin 1's not really doing much, I don't think. It's just basically filtering stuff. Pin 3 maybe getting mixed with this. Maybe it's kind of filtering through here as well. So pin 2 and pin 6 I think are the main ones we need to look at here. This FT104 is that big filter which does the bandpass, and this is one people tend to play with if there's no sticker over the top saying do not adjust. They need to get played with and they get messed up. So like I said, I spent about 10 minutes adjusting just those bandpass filters on here. Anyway, we'll check pin 2 and pin 6 to see what's going on there. Okay, so here's the waveform on pin 6. This is on FM, and here is on AM. Frequency is the same, waveform is the same. If you go to transmit, it's still there. It dips a little bit, but that's okay. And FM also dips a bit, but here you can see the frequency modulation happening. FM is doing what I expect, and AM is also doing what I expect on pin 6. So that looks okay. If you go to different frequencies, the frequency here is changing. Well, sorry, different modes. Right, so FM is 37.0258 according to my scope. So is AM. Upper sideband is 0283 and 0233 on lower sideband, and CW is 0258 as well, which is what it should be. So the frequencies at that point looking correct. So pin 6 is looking fine. So now we look at pin 2. So trying to measure pin 2 is quite hard because the frequency that is there is extremely weak. And I've seen this before. Let me just go back to here. Let's work out what frequency we should get. So on pin 6 we're getting 37.0258. What frequency are we on? 26.330. Let me work this out. So we should be getting a 10.695 megahertz signal there. Let's go back to pin 2. Problem is, when you transmit, which is when you get the IF, the TX power overpowers it. Right, so if I go to transmit on FM, all you're seeing there is a 26 megahertz signal there. You don't really see the IF frequency. It's being overpowered. If you go to AM and do the same thing, go to switch to TX, you can see something there, but that's actually a feedback. It's a feed through of the 37 megahertz. It's bleeding through. Right, so it's not actually that one we want. I've changed my probe to 1 times as well. I should go back 10 times, just trying to get more sensitivity out of it and reduce noise. But yeah, it's not helped. And that's on sideband. That's the beep coming through. So if I modulate that, trying to measure that frequency, that 10.695, is always a pain. But that's what I'm thinking now. Okay, so we know we've got one of the frequencies there, but I'm guessing the 10.695 isn't getting steered through on AM. So that's where I'm suspecting we need to be looking next. So now moving on to the balanced modulator and just checking the IFs in and out. So the IF comes in here to the balanced modulator. Get modulation comes in this way, and this is a switch and stuff like that for the modulation modes. And IF should come back out of here. So if I probe on D122, you'll see on the scope in a second, you can see the IF's coming out. So let's have a look at this. So D122 is right there. I'm going to transmit. So there's the FM. AM's got nothing there. SSB, you can see the IF coming out when the bleep comes off, because I've got the beeps turned on. So there's the beep, doing the IF. Go to AM, did a beep on that one. You do see modulation there. Do kind of see something. It's very noisy though, right? FM, no problem at all, there's a carrier. And that's kind of what I expect to see on AM as well, but it's not there, which is a bit strange. So what I'm going to do now, I'm going to go down to pin 3 of the IC105, which is down this bottom side here. So we're going to look at C54, C53, around that region. It's actually C54, C53 junction I'm going to look at. So that's a jumper wire on this board. Stick that on there. I've got the jumper plug pulled out for the RF section so that the RF doesn't interfere. I've also got 20 MHz bandwidth on here as well to help filter out noise. Let's go. There's upper sideband. There's lower sideband. There's the IF coming in before it's filtered by the balance modulator. AM's got nothing there. FM's got nothing there. When you transmit, there's the FM one, which is fine. AM is missing. So that IF comes in through this capacitor C53, comes from down here, which is the IF oscillator, right? And this has got various complicated switching through diodes and stuff over here, and this is quite a lot to it. Now that's fine. So what I'm going to do is check at D104. The reason I want to check at D104 is because that is where the AM power comes in. So the AM switching in TX comes through here, right? As that switches this oscillator on in TX and AM, okay? Because it's switched on and off and things like that. It's quite complicated. So we'll check at D104. I've got the probe ready. I've already found the diode. So we're probing D104. I've got my scope set to DC coupling and everything as well now. So I'll go to TX on there. There you go. There's a voltage offset. So that's switching. We've got an FM. Looks exactly the same. So AM and FM should be exactly the same, and they are. That's in TX. Go back to RX. And this is on sideband. Upper sideband, lower sideband. And CW. Okay, you can see there's slight differences in voltages there. That's because of the diode steering they use. So that's not unsurprising, that's normal. So FM is exactly right, and AM is also exactly right. So that should be turning the oscillator on. So that's fine. So at that point it's not an issue. So I need to look a bit further down. So now I'm going to look at C82, which is over here. That's the output of the oscillator. If I measure the output of the oscillator right here, I should be able to see the oscillator frequency on the sidebands and AM and FM on transmit. So if we go to that point there and probe that, so this is the output of the oscillator. So this probably will affect the oscillator frequency while probing it, but not worried about that. So it's got a sideband, there we go, DC offset, and there is oscillation there. Okay, so let's just make this a bit bigger. Yeah, let's go AC coupling, turn the DC offset off. Says AC coupling. 10.6927 according to the scope. On lower sideband, upper sideband, 10.6977. I'm not worried about the actual accuracy of the frequencies right now. I haven't done a calibration yet. I'll worry about it later on. So that's close anyway. AM is nothing there, FM is nothing there, which is correct. This is on receive. Go to transmit on FM, it's there. 10.695, that's correct. Go to AM, there's nothing there. So the AM transmit, for some reason, it's not there. Well, that's curious. Let's check D70 here, or D170, which is supplying L106. I'm going to show you what I found. So I'm just going to go and probe onto that. That's actually right next to the crystal, so it's a nice and easy thing to probe onto. I'm in receive right now as SFM, it's AM, upper sideband, lower sideband CW. Right, in all cases that's high, which is a little bit interesting in itself. Yeah, anyway, go to transmit. That's high on FM, low on AM, low on upper sideband, low on lower sideband, and high on CW. Right, so this is what I'd actually expect, is to have FM high, CW high, but AM, which has got nothing there. I'd expect that to be high on transmit. So something is wrong there. I need to track this back further. So I was checking around here, D171, which comes up here. That's 171 there, that's 172. I need to move these markings around, make it a bit tidier. Anyway, so D171 is here, which is a bit tight to get into, but I can just about get in with the Pro. So on the side that feeds the coil, there is nothing there. That's on AM receive, AM transmit, nothing there. If I go to the other side of the diode, we have a voltage. AM transmit and receive. Go to FM, it disappears. Sidebands disappears, CW disappears. Right, so it's only AM is this one here passing through, but it's not passing through. It's not there. If I go to FM, then it shows up. So that diode is probably dead. I think that's wrong. So what I'll do is I'll just drag over and I'll show you that. So I follow this line, try and follow it on screen if you can. It's a bit hard, but it does follow all the way over here, and it goes to the AM from the band switch over here, which you can probably not quite see because the oscilloscope's in the way. There we go. So that's 8 volts comes through and shoves it through there. So that is getting to the diode, but it's not coming back out of that diode, so that diode must be blown. So it's actually measured the diode to be absolutely sure that's what's wrong. So I'm going to just get in here like I said. So watch the meter over there. So I'm going to go backwards first. So yep, that's fine. That should be nothing that way. And turn it around this way, we should get something. We should get diode drop. So it should be about 0.6 volts. Nah, nothing there. See, nothing. That diode is dead. Excellent, looks like I found it. Well, I'm going to try and show you where the diode is. So I've got these inductors over here, which are filters to stop RF leaking out of the switching system where it supplies DC in. And just there is a diode, right there. That is the one I'm talking about. That's D171, right there. Just down the back there, and that's the one which is not working properly. Alright, so there's a dead diode out. So I'm going to put a new one in. It's actually quite easy to work on this radio because the MPU bolt, this is the chassis. You can just undo the 4 screws to each side. You can just take the chassis piece out and get to the back of it. It's really handy like that. It's quite a nice design. So we'll get this new diode in, then retest and see if we have our issues solved. I'll be really surprised if we don't. Alright, got it in place. Solder it in. Okay, that should now work when I clip that lead off and try it again. Right, moment of truth, let's plug the power back in and see if we're going to have life out of it now. Let's put the jumper back in again. We've got transmit. Yay! There goes the bird watt meter. So FM transmit, AM transmit, yeah, sideband Aussie, nothing there, and CW Aussie as well for the same reason, but obviously the beep goes off, that works. But AM is now working. By looking at this radio here, hopefully you can see it on there. That's why you can hear it, because it's coming to that radio. So yes, that is fixed. Brilliant. So I'm going to program that balance modulator again. I'll show you the signals I now get compared to what we got before, so we can see what it's supposed to be like. So if I go to D122, which is the output out of pin 7, so we're setting a DC offset there, transmit, there is something there. AM and FM are now the same, that's FM, that's AM. Go back to receive, just DC offset. So if I go back to AC coupling and wind the sensitivity up a little bit, you better see a bit more. So transmit, here we go, there it is, and there's FM. So AM and FM exactly the same. That's exactly what we expected. Sideband nothing until you get a beep, right? Or audio coming through it, and AM should just be there. Okay, so that is working. If I go a bit more, make it a bit more sensitive. So there we go. There's the carrier there, and there's FM, AM, and that's on the output. So that's exactly right. So if I now go to the input, which is on that junction of C53, C54 on pin 3. So we go to transmit again. There we go. There's the IF going in. Alright, it's noisy, but you know, there's lots of stuff going on here. That's sidebands and transmit, AM transmit, FM transmit, and I've got obviously just general noise around the place. Okay, so it's working. So that noise that was getting before was my soldering iron. I've just turned it off. So there you go. There's the carrier there. FM, AM. That's why it's no longer got those pulses there. You're talking about really low levels. You know, that's why it's really hard to measure these things. That's 200 millivolts of division. So we're talking about really small levels on these things. It now does what it's supposed to do. And if I now go and measure on pin 2 of the TX mixer, which is up there, which is what we looked at before and didn't have anything there. Pin 2, let's go to transmit. There we go, there it is. Right, so previously we had nothing there when we went to transmit. We could see nothing. And if I do FM, exactly the same. Right, so FM was there before, although it was masked by the transmit waveform. Actually, I'll pull that carrier back out again. Let's do that. Make sure we're not getting noise from that. Transmit on FM, there we go, there's the IF. Okay, 10.695 it should be, but obviously you can trouble reading it. And transmit, and then AM, exactly the same. Which is why I said before, AM and FM should be identical. There shouldn't be any difference between the two in those aspects. That's definitely what we should be getting there. So it also shows you what you should be expecting if you're looking at one of these radios and then try and troubleshoot what signal should be there. Right, so you can see that's only at 50 millivolts of division, and that's the size of the waveform. It's really, really small. It's not a strong waveform at all, so you can actually very easily miss it if you don't have your scope set up correctly. You know, there's also AC coupling the bandwidth limit of 20 megahertz to try and help keep the noise down. All that sort of stuff is quite important. So earlier on I talked about the biasing and everything on the final and that sort of stuff, and why I was getting that weird issue with the biasing and the increasing currents with reducing RF power at the same time. That's due to that leakage via the transistor, the final transistor. So I'm going to point this out now. So this is the final transistor here. This is the bias adjustment, which I had to turn right down. So that was basically trying to short out this rail to drag this voltage down to stop this being DC bias. Now the DC bias, what it does is it partially turns the transistor on. Because you're trying to pass a signal through, and it's not just switching on off, you're actually getting a waveform, you have to bias it onwards. Having it biased on means it will transfer anything it's getting straight through and amplify it. If it's not biased on enough, it will be clipping a little bit, or it won't be turning on fully, it'll only be partially on, and so only part of the waveform will transfer through. Sometimes you actually want that, but in this case you don't want that. We want it to pass the whole waveform and amplify it. So that's why there's a DC bias on the final. There's a driver bias over here. What's happening is the DC bias from this was leaking back through this bias circuitry and pulling this one up. Right, it's actually pulling this whole thing upwards, because this is a 13.8 volt supply leaking through, and this is an 8 volt rail, which actually comes out being about 7 volts in the end by the time it goes through the switching transistor. So about 7 volts coming through this rail, which should be feeding this biasing, and because this was pulling it upwards in voltage, it was messing up with the biasing a whole lot. So that's what was happening there. So that's why those biases should be about 0.6, 0.7 volts around there somewhere. It depends on the transistors a bit and the circuitry and how it's tuned. But these are set for 50 milliamps. So what you do is you pull that jumper out there and you set between the common rail for the supply, which is this one here, this line comes along. So TP4 is the common. And you do TP2, which is the driver. It ties onto the collector through the inductors here, there's filters. You do that one, and then you set at 50 milliamps, and then you do the other one, which is for the driver, of course TP3 and 4, for 50 milliamps as well. Normally, but because I've changed this transistor, it's going to be different. I haven't looked at it yet, obviously, because I haven't actually done the alignment. I don't know what I'm going to get. I'm going to do that separately. Yeah, it seems pretty good. Don't forget to like the video if you quite enjoyed it. Subscribe if you're not already subscribed, and click the bell icon if you've not been here before. I do CB stuff from time to time when I get the chance, when I get the inclination. This will be it for this video. I'm going to finish this one off. You don't need to see any more than that. It's just an alignment thing. It's not that exciting. I'll catch you later. Bye.